Okay, so we were on page 167, and we're going to do derivatives of higher order. So what we're doing is within the implicit direct differentiation, now we're going to do not just only the dy dx, we're going to do y double prime also. So let's see how that works. Example 5. So really this is the same thing. The only difference here is that you will do some other stuff once you find the y prime, once you find the double prime. Okay, so here we go. 2x cubed minus 2x cubed minus 3y squared is equal to 8. So let's find the y prime first. We're trying to find this guy, the double prime first. Let's find the y prime first. So I'm going to get 6x squared minus 6y, y prime is equal to 0. So I'm going to get, the 6's are going to cancel out, so I can cancel those out. I'm going to get y prime is equal to x squared over y, which is just fine, okay? So we're good here. So now we have y prime, so let's find y double prime. Since we have this guy, we'll start with this guy, and from this guy, we're going to do the quotient rule. So it's going to be low d high, so low d high, and take the derivative of the high, 2x minus high d low. So you take the derivative of the low, so that's what we get. It's going to look like that, but, so from here, what do we have? We already know that y prime is equal to x squared over y. So we can actually put this back in here. Okay, so what we're going to do is we're going to say this is going to be y 2xy minus x squared times, I'm going to put y prime into here. So I'm going to get x squared over y squared. Okay, so if I do that, if I now take the y down here, I'm going to get what? 2y squared x minus x to the 4th over y cubed. Okay, is that correct? Yeah, looks like we're good. Okay, so this is going to be your answer. So the only thing that was different here is that once we were done, we were able to put this y prime and put it back in here and go further. So we don't want to have y prime within the expression of y double prime. Okay? So that's that. That's how you do that. So on the bottom of page 167, now we're going to talk about rational powers of differentiable functions. If you flip the page to page 168, you have the same power rule here, except for now it is going to be applicable to any type of rational, n is any type of rational number, okay? So there's nothing really new there, okay? Let's go to example number 7. I want to go to example number 7. Now this is quite interesting. So if you understand example number 7, you're good to go with implicit differentiation. So this is pretty complicated, not necessarily complicated, but sometimes it can be confusing. So let's go to example number 7. Example number 7, there are 3 separate examples here. And here are, so let's read the question. Here are 3 multiple choice questions that most calculus students get wrong because they fail to handle the chain rule properly. Okay, so let's see what we can find. So on A, or it's number 1, I guess, not A, on 1, we have dy dx is equal to dy dx is equal to 1 plus sine y, and we are going to find y double prime, basically. So we're going to find this. So we're going to take the derivative of this guy. So what do I get here? So if I take the derivative here with respect to x, this guy goes away, and I take the derivative of this, which is going to be cosine y times, I have to do the chain rule. is going to be y prime here. So what is y prime? Y prime is this guy right here. So I'm going to have cosine y times 1 plus sine y, which is cosine y plus cosine y sine y. We have something that looks like that. Looks like it's E. So the answer is going to be E there. Okay. All right. See how that worked? Okay. Again, we're taking the double derivative. So in the double derivative, again, we don't want the y prime in there. So we substitute the y prime back in here. This is what we get. Okay. So that was number 1. To number 2. Number 2, we have if x is equal to sine t and y is equal to cosine t, and find y double prime here. We're trying to find y double prime. So what is y prime here? So we're going to get y prime is basically equal to dx dy dt over dx dt, right? So what do we have? Dy dt is what? Negative sine t. Dx dt is cosine t, right? So we're going to get what? Negative tan t. Negative tangent t is y prime, and I want to get y double prime here, right? To find y double prime, what do I get? Y double prime is equal to what? We're going to get y double prime is equal to, or basically the negative tan t, derivative of that. Okay, so it's going to be the derivative of that is going to be equal to the negative tan t. So negative tan t is negative secant squared t over dx dt, which is dx dt is equal to cosine t, right? Cosine t right there. So we're going to get, this is secant again. So we have negative secant cubed t. Do we have anything that looks like that? Looks like it's E again. Okay. Again, you have to not mix the t's and the x's and the y's. You have to keep these all straight. Okay. Last but not least, we have number 3, and number 3 we have y is equal to ft squared and f prime x is equal to 2 minus cosine x. And we're trying to find dy dt, which is this guy right here, right? So it's going to be f prime t squared, right? And then we're going to have to do what? The times a 2t, right? So what do we get? If we do that, we're going to get 2t times this guy, which is nothing more than putting t squared into this guy, 2 minus cosine t squared. Okay. And we have something that looks like that. Looks like it's B. So everybody understand where this came from, right? This is the derivative, the chain rule of this guy here. Okay? Again, you have to keep the x's and the y's and the t's all straight here. Okay? So looks like we're done there. Oh, by the way, I already went ahead and changed or corrected